Go.
Hi, we're Team 1069E Critical Mass, and this video is for the Create US Open High School Division for the VEX 2019 game Turning Point.
Hi, I'm Matthew, I'm a senior, and I'm the programmer.
Hi, I'm Lily, I'm a junior, and I'm a driver and builder.
Hi, I'm Ellie, I'm a sophomore, I'm a notebook writer and a builder.
My name is Andrew, I'm a junior, and I'm the main builder.
I'm Emily, I'm a sophomore. I worked on online challenges and I helped build the robot. And one of our team members, Julian, who is a junior and is a driver, is not here tonight due to illness.
So this season, we've been very successful. We won the Excellence Award at our state competition. We've won multiple design awards, and we've been skills champion multiple times throughout the season. So with the robot we have, the most difficult part of it has easily been the intake. We've gone through a variety of different designs, including multiple rubber band rollers, a couple of conveyors, one on both sides. We've had conveyors at angles, and overall we've decided on a single conveyor going up and a single rubber band roller to bring it in. So with the intake, the best part of our robot is easily the shooter, as it is very accurate and it is our biggest strength for us. We can get a ball and we can shoot two of them at about the same time and just go back to back and hit the high flag and the middle flag.
There's a lot of improvements we can make with our robot as well, and one of those is our programming. We have struggled to be able to drive straight during autonomous throughout the year, and one of the things that we have worked on to help fix that is a function that allows us to adjust the different sides of the robot if one is falling behind.
One major part of us for VEX, because it's not all about the robot, is how we impact the community. And we've done that through volunteering at a summer camp for Lego Robotics. We volunteered at VEX IQ tournaments, and we've demonstrated at our local elementary and middle schools.
We've also submitted multiple online challenges, one of which is a girl-powered essay, which actually ended up being a finalist. We submitted multiple VEX photography entries along with a CAD online challenge.
We utilize a lot of code and sensors in our robot as well. The sensors we use are a vision sensor to detect whether we have the ball in our shooter or not. We use an ultrasonic sensor to determine how far from the wall we are, a gyro to measure our turns to make sure we're turning the right amount, a potentiometer to measure our shooter angle so that we make sure we're at the correct angle, and a button sensor that we use in skills to line up with the walls.
So one thing that we found was very helpful for us is the way we practice driving is we will make a skill strategy, and then we'll just practice that over and over again, and I'll make a new skill strategy, and we'll just keep trying to top ourselves in skills. And we found that that helps us in both qualification and elimination competitions.
So as you can see, our robot is modular, which allows us to all work on the robot at the same time without running into space constraints. So what we have here is our shooter, and then right here on the back is the intake. We have a 4-motor base geared for speed and power, and a single arm for both descoring and flipping caps.
So the first thing we did at the start of the season is just gave out as many ideas that we could for this game after watching the video and reading the rules, so we kind of knew the regulations that we had to follow. And so by doing this, later on in the season, if something went wrong, we could fall back on that huge list of ideas, so we wouldn't have to sit down again and start brainstorming over and over and having to repeat that process too much. A big example of this is our arm. We started off the season with a 6-bar lift and something that could put the caps up on the posts. However, we found this to be very heavy and take a lot of time, so we fell back on one of our previous ideas of having just a single arm to flip caps on the ground and descore them off of posts.
Once we had these ideas, we turned them into reality and then used those prototypes to determine which one would be our final one. An example of the testing we put these through is our shooter. We built both a flywheel and a slip gear, and then shot several times at a whiteboard and marked with a land, which allowed us to see that not only was the slip gear more powerful, it was also more accurate and therefore the better choice for our robot this season.
Every prototype we did and every decision that we made at every single meeting went into our notebook, so that way if anything were to ever break or we needed to rebuild something, we knew exactly how to do that by a step-by-step basis we wrote in.
After every tournament, we also reflected both personally and we wrote in scores and statistics from that tournament, so we could see what we needed to improve on in the future based on personal aspects along with what the skills and statistics shows that we needed to do.
We've also included some coding examples in our notebook. Some of these include our PID control for our shooter, our gyro turns, and our vision sensor detection code.
We also have a repair chart for the robot, color-coded for ease of use, which allows us to, after every competition or every practice, look at the robot and say, what do we need to fix, and what are these common problems that we can avoid by using this chart.
All right, let's show you how the robot runs.
Thank you for your time.